Hi everyone, this is Kiranmay from H&S department. Today we are going to discuss about Introduction for Quantum Mechanics, Wave Particle Duality, Debroglie hypothesis, matter waves and its characteristics, Schrodinger wave equation, and physical significance of wave function. First, what makes the quantum mechanics to came into existence? That is, the failures of different theories. The first one is failure of classical mechanics. Failures of classical mechanics are as follows. The stability of atom. Classical mechanics cannot explain these terms: stability of atom, spectrum of black body radiation, photoelectric effect, Compton effect, Zeeman effect, and Raman effect. Especially the stability of atom. Why classical mechanics has failed to explain stability of atom is, according to classical mechanics, energy is a continuously decreasing quantity, which is not happening with an atom, because in an atomic structure, electrons are continuously revolving around the nucleus. If the energy is continuously decreasing quantity, electrons energy at some point should be decreased and become zero, and electrons should fall into the nucleus, which is not happening actually. So classical mechanics mainly failed to explain the stability of atom. Further, there are many more theories which had tried to explain the failure concepts of classical mechanics. In that, the first one is Newton corpuscular theory, where they had considered light as a minute particles called as corpuscles, but they had failed to explain interference, diffraction, and polarization. After that, Huygens wave theory and Maxwell's electromagnetic theory came into existence, but they had successfully explained the phenomena of interference, diffraction, polarization, but failed to explain different effects like photoelectric effect, Compton effect, Zeeman effect, and all. So at last, finally, in 1900, Max Planck came to existence, and he proposed quantum hypothesis to explain all the failure concepts of the previous theories. In his quantum hypothesis, he mainly presented 5 ideas by which he explained the failure concepts. The first idea, according to him, is energy is not continuous but comes in small and discrete units. Second idea, the elementary particles behave both like particles and as well as waves. The movement of these particles is inherently random, and it is impossible to know their both position and momentum simultaneously. And the atomic world is not like as we live in. These are the 5 ideas what he presented in his quantum theory to explain all the failure concepts of previous theories. Okay. So according to him, wave particle duality, which means that how a wave behaves like a particle and how a particle behaves like a wave. Before that, what is a wave and what is a particle? Wave is nothing but a disturbance which is created in space by transfer of energy from one point to another point. Wave is nothing but a disturbance which is created in space by transfer of energy from one point to another point. And it is specified with the terms called frequency, wavelength, phase, velocity, amplitude, and intensity. Then what is a particle? A particle is having certain mass which is located at some position in the medium. But we cannot locate a wave here and there in the medium, but we can locate a particle with its mass and position in the medium. The particle is specified by its mass, velocity, momentum, and energy. In the year of 1924, Louis Debroglie has suggested how matter has dual nature, how a matter can behave both as a wave and a particle. Okay, for his concept, he considered that as the radiations is having the dual nature, why not matter is having dual nature? If radiation can behave both as a wave and particle, why not matter can behave like both particle and a wave? By considering this concept, he had successfully explained photoelectric effect, where light radiations is having particle nature. So according to Debroglie, the matter wave is defined as a wave which is associated with moving material particles, a wave which is associated with a moving material particles. In his hypothesis, he combined the particle nature of a matter with wave nature, particle nature of a matter with wave nature. For his, he took two equations help. One is Planck's equation, another one is Einstein's mass energy relation. Planck's equation is nothing but E equal to h nu, and Einstein's mass energy relation is nothing but E equal to mc square. By taking the help of these two equations, he combined wave nature with particle nature, wave nature with particle nature. Particle nature mc square is equal to wave nature h nu. Just by replacing the terms, as we know that velocity of light can be given as a product of frequency and wavelength, c is equal to nu into lambda. Just replacing the terms in the equation, in the above equation, mc square is equal to h nu. In place of nu, they had replaced it with c by lambda. Now cancelling both sides, velocity left with mc is equal to h by lambda, lambda is equal to h by mc, where mc is nothing but mass into velocity, which is given as momentum. So lambda is equal to h by p, where lambda is called as de Broglie wavelength in terms of momentum. This equation is called as de Broglie wavelength in terms of momentum. Now to convert this formula into the velocity terms, just take a particle of mass m moving with a velocity v. Then we can give its momentum as mass into velocity. So therefore, we can give wavelength as lambda is equal to h by p, just replacing momentum with mass into velocity, h by mv, which says that de Broglie wavelength in terms of velocity. This equation is called as de Broglie wavelength in terms of velocity. We are having a number of formulas for the de Broglie wavelength. Before slide we had seen wavelength in terms of momentum. Here wavelength in terms of velocity. Next, wavelength in terms of kinetic energy. How to prove it? So for that, consider a particle of mass m moving with a velocity. So obviously its kinetic energy will be equal to half mv square. Now just multiply mass on both sides. You will get 2me is equal to m square v square. Root 2me is equal to mv. Just got the square from one side to another side, it will become square root. So mv is equal to root 2me. So if you replace the same term in the de Broglie wavelength, lambda is equal to h by mv. In place of mv, just replace it with root 2me. You'll get lambda is equal to h by root 2me. That is de Broglie wavelength in terms of kinetic energy. This is the third formula. Then de Broglie wavelength in terms of potential. How to derive it? For that, consider a charged particle which is having mass m, moving with a velocity, having charge q. These are the terms which are required for the charged particle. That is, its mass m, velocity v, and its charge q. So now we can give the energy of the particle in terms of velocity and also in terms of charge. In terms of velocity, half mv square. In terms of charge, qv. So just by equating these two, you'll get m square v square is equal to 2mqv. So mv is equal to square root of 2mqv. Just replacing that in de Broglie wavelength, you'll get lambda is equal to h by root 2mqv. This is called de Broglie wavelength in terms of potential. Then this is the formula where we are going to derive de Broglie wavelength, especially for electrons. For that, consider an electron of mass m moving with a velocity v and charge e, and it is accelerated to a potential v. So in the before formula, in place of q, just replace charge with e. So lambda is equal to h by root 2 mv. Now as Planck's constant value is constant, 6.6 in 10 power minus 34. M, mass of electron is constant, 9.1 into 10 power minus 31. Charge of electron is constant, 1.6 in 10 power minus 19. Taking all these values and substituting them in the formula, you'll get lambda is equal to 12.26 by root 3 Armstrongs. This is the de Broglie wavelength, especially for electrons in terms of potential. De Broglie wavelength, especially for electrons in terms of potential. Now the characteristics of matter waves, as we had derived the formula for de Broglie wavelength. Using that, we are going to give the characteristics of matter waves. So what is a matter wave actually? It is a wave which is associated with a material particle of mass m and velocity v. The first characteristic is lighter the particle, greater is the wavelength. See, if the particle is lighter, mass will be less. If mass is less, obviously wavelength will be high, as they are inversely related to each other. Lesser the velocity, longer will be the wavelength. If velocity is less also, wavelength will be very high because both wavelength and velocity are inversely related to each other. If velocity is equal to 0, if velocity equal to 0, what happens? The denominator term will become 0. So you cannot find its wavelength. That means that the matter waves are associated only with moving particles, not with a stable particles. Okay, only the particles with certain velocity are associated with matter waves. Since in this term we didn't find any charge terms in this formula, as we didn't find any charge terms, whether the particle is charged or not, matter wave will be associated with it. So if you if the particle, whatever the particle you had taken, if it is a charged particle or not, but if it is in movement, definitely it is associated with a matter wave. So matter waves can travel faster than the light, as the wave velocity of the matter waves is 1 by v into c square. So obviously its velocity will be little bit faster than the light velocity. Particle and wave nature cannot be existed simultaneously. At a given point of time, either we can observe particle nature or a wave nature. These are the certain characteristics of matter waves. Now, for this matter wave, we are going to derive a wave equation using Schrodinger. He is the scientist who had proposed a wave equation for the matter waves. In 1926, Schrodinger had developed a wave equation for moving particles. Moving particles are nothing but matter waves. So in 1926, Schrodinger is the scientist. He proposed or developed an wave equation for matter waves. For the derivation, he considered a particle of mass m moving with a velocity v. Okay, here the matter wave associated particle is having a mass m and they are moving with a velocity v. Let psi be the wave function. So psi is equal to psi naught into sine omega t minus kx. As we have seen in the simple harmonic version, x is equal to a sine omega t minus kx. In the same way, in this quantum mechanics, we are going to take wave function psi is equal to psi naught sine omega t minus kx. So psi naught is the constant value, omega is angular frequency, k is called wave constant, whose value is given by 2 pi by lambda. Now differentiate this psi with respect to x for twice. With respect to x for twice. So differentiating it for twice, we'll get dou square psi by dou x square is equal to minus k square psi naught sine omega t minus kx. This psi naught sine omega t k minus x is nothing but psi. So in place of this expression, we are just replacing it with psi. So dou square psi by dou x square is equal to minus k square psi. So getting that negative term onto the other side, it will become positive term. Dou square psi by dou x square plus k square psi equal to 0. Dou square psi by dou x square plus 4 pi square. We are just replacing k with 2 pi by lambda. K square is equal to 4 pi square by lambda square psi is equal to 0. And as we know that Debroglie wavelength associated with a matter wave is h by mv. So in place of lambda, just replace h by mv. The equation can be rewritten as dou square psi by dou x square plus 4 pi square m square v square by h square psi equal to 0. Now, just to replace this m square v square with energy terms, consider E as total energy, K and V as kinetic and potential energy. As we know that total energy is equal to kinetic energy plus potential energy. Just rearranging the terms, kinetic energy is equal to total energy minus potential energy, that is E minus V. So kinetic energy can be written as half mv square, that is equal to E minus V. Just multiplying both sides with m and getting 2 onto the other side, this equation can be rewritten as m square v square is equal to 2m into E minus V. Now in the before equation, just in place of m square v square, we are going to replace it with 2m into E minus V. So just replacing it, rearranging, multiplying the terms, you'll get dou square psi by dou x square plus 8 pi square by h square m E minus V of psi equal to 0. Now in this, we are going to replace it with a special operator called h cut. H cut is equal to h by 2 pi. Now h cut square is equal to h square by 4 pi square. Just replace in this term, you'll get dou square psi by dou x square plus 2 by h cut square into m E minus V is E minus V of psi equal to 0, which is called Schrodinger wave equation in one dimension. Schrodinger wave equation in one dimension. As you can see, only x terms in this equation. This is Schrodinger wave equation in one dimension. If you want to convert this into three dimension, just add other two dimensions y and z. So in three dimension, dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square by h square m e minus v of psi equal to 0, where psi here in this equation, it is a function of x, y and z. Now using Laplacian operator, that is del square, you can replace dou square by dou x square plus dou square by dou y square plus dou square by dou z square with del square. So replacing it, you'll get one expression del square psi plus 2 by h cut square m e minus v of psi equal to 0, which is called Schrodinger wave equation in three dimensions. As there is no time dependent factor in this equation, this equation is otherwise called as Schrodinger time independent wave equation. Schrodinger time independent wave equation. Now, the physical significance for the wave function. See, wave function directly doesn't have any physical meaning. When it follows the following conditions, what are the conditions prescribed here, then only that psi is called as a wave function. To explain the relation of particle to wave packet, Born has proposed the physical significance of psi. See, multiplying psi with its conjugate will give you the probability of finding the particle. Psi star is nothing but modulus psi square. That is, psi square is a measure of probability density. That means what was the probability for a particle to be being in that state. That probability can be given by a product called wave function with its conjugate. Now, if you take the volume integral of this psi star, that will be equal to 1, which is called normalization condition. If we want to call psi as a wave function, psi should satisfy this normalization condition. Then only we can call psi as a wave function. Normalization condition is nothing but volume integral modulus psi square dx dy dz is equal to 1. Along with this normalization condition, psi should also satisfy three more conditions. One is psi should be a single valued function, continuous function, finite function. Why it should be a single valued function? If it is a multi-valued function, we will have a multi-valued function, we will have different solutions at last, which is not possible. So to have psi has to be a wave function, psi should be a single valued and finite function. And if it is a discontinuous function, what happens? Dou square psi by dou x square does not exist for a discontinuous function. But as per the wave equation, dou square psi by dou x square should exist. If so, psi should be a continuous function. So if psi should have certain meaning as a wave function, it should satisfy four conditions. One is normalization, another one is single valued function, continuous function and finite function. If psi can satisfy all these conditions, definitely psi is called as wave function. Thank you.